Good afternoon, everyone. My topic is Kosaraju algorithm. So, before learning Kosaraju algorithm, we need to understand what a strongly connected component is. So, in a directed graph, you can travel from one node to another node and come back to the first node by following the direction of edges. Then those nodes form a strongly connected component. Now, let's take an example. In this directed graph, if I take this component and this component, then are they strongly connected component? The answer is no, because from third node you can travel to fourth node, but from fourth node you can't travel to third node. So this is not a strongly connected component for this given graph. So if I take this component and this component and this component, then these are the strongly connected component for our given graph because we can travel from first node to another node and come back to the first node by following the direction of edges. The question is, can a single node be a strongly connected component? The answer is yes. If no edge is connected or it forms a loop to itself, then it is a strongly connected component. So now coming to the Kosaraju algorithm. Kosaraju algorithm is a DFS based algorithm used to find strongly connected component in a directed graph. Other than DFS traversal, it also involves reversal of graph where all the edges get reversed and strongly connected component will remain a strongly connected component after even reversing its edges. So this algorithm has three steps. First step is perform DFS and store its finishing order. Means run the DFS on the original graph when vertex finishes all neighbors are visited, push it into a stack. Now second step is come to reverse the graph. By reversing the graph means reverse the direction of all the edges in the graph. Now step third comes do DFS using stack order. Means pop vertices from the stack one by one. For each unvisited vertex perform DFS on the reverse graph. The nodes reached in each DFS form one strong connected component. Let's take an example. So this is our directed graph. So we do DFS traversal over each node and push node into a stack when it gets missed. So for this we need to take an array to keep track of visited nodes and a stack. So this is our visited array and this is our stack. So starting from 0, traverse it and mark it as visited, and from 0 there is only one outgoing edge that is going to first node. Traverse it and mark it as true, and from first node we go to 2, traverse it and mark it as true, and so from second node go to third node, mark it as true, and from third node go to fourth node, mark it as true, and from fourth node go to fifth node, mark it as true, and from fifth node go to sixth node, mark it as true, and from sixth node go to seventh node, mark it as true. Now 7 has no outgoing edges, so it has no child node to visit. So we will push the 7 into the stack. As you can see this, I push 7 into the stack. Then 6, then 5, then 4, then 3, then 2, then 1, and then 0. Now we come to our second step, that is reverse the graph. Reverse the graph means reverse the edges of graph, direction of the graph. In this, so in our second step, I have reversed the direction of edges in our graph. Now, now step third comes to start AFS again from the top of vertex on the step. So which is in our case is 0. Mm, this is. So we pop 0 and start traversing graph from 0 and mark it as visited. From 0, we can go to second vertex, we will mark it as true, and from second, we will go to first node and mark it as true. Now from first node, we again come back to 0, which is already visited, so we get our first strongly connected component, that is 0, 1, 2. Here we have done with this DFS traversal, we get a stronger kinetic component. Moving forward, we still have nodes in the stack. So repeat the process, keep going the node, keep popping the node until we get unvisited node. So we will pop first node, second node, and we will come back to third node that is unvisited. Unvisited. So we will repeat this process and we visit third node and pop it. Then from third node we can't go to any other node. So third itself is a strongly kinetic component. So from we came back to fourth node. From fourth node we can go to sixth node, then fifth, then come back to fourth. So 4, 6, 5 is a strongly kinetic component. Then we pop 4, 5, 6, 7, and also maintaining the visited array. Then there is only element left in our stack that is 7. We visited it and pop it. Now we have all our strongly connected component that is 0 to 1, 3, 4, 5, 6, and 7. Now coming to the pseudocode, we have created a stack which is empty and a visited array which is false. Now first step is DFS. We will perform DFS, then second step is we will reverse the graph. Then third step is we will again do DFS using the stack order. So this is the Java code for this algorithm. You can see this. And now coming to the time complexity. Kosaraju algorithm has a time complexity of big of b plus c, where b is the number of vertices and e is the number of edges. This is because we perform DFS twice. And the space complexity is also big of b plus c because we use a stack and adjacency list. So now thank you everyone